everyone, a very good morning. I am here from studyED to revise chapter Mensuration of Class 8 from the NCERT syllabus, chapter 11 in the book. Let's now begin with the lesson. So, in terms, what is mensuration? Mensuration basically means the measurement of area and perimeter of different geometrical shapes such as triangles, trapeziums, rectangles, circles, squares, etc. Well, you name it. Shapes in general. Let's just revise through the areas of different shapes we've learned through in the past grades. Rectangle A into B or LB, where L is the length and B is the breadth. Square is A into A square or S square, where S is the side of the square. Triangle 1 by 2 BH, whereas in 1 by 2 base into height. Parallelogram is base into height, BH. And circle is pi r square, where r represents radius. Let's now move on to the next slide. We're going to revise some very important shapes, areas and perimeters as we go through this lesson, starting off with area of a trapezoid arrow trapezium. Now, this is what a trapezoid or trapezium looks like. Observe this figure. You see it's a figure like the size of a triangle, but the length as a rectangle. We can also infer that the height is denoted through h, the first length is denoted to b1, the second length is denoted to b2. So, what is the area formula of a trapezoid? Area is equal to 1 by 2h b1 plus b2. To simplify this, it's half the height into b1 plus b2, or length 1 plus length 2. H the height, b1 parallel length 1 and b2 parallel length 2. Now we can easily understand the formula and memorize it as in 1 by 2 bh b1 plus b2. However, instead of doing that, let's find out how is the formula derived so that we have a more in-depth understanding of the topic. Let's take this figure for example. You can see a trapezoid with various lengths given and denoted as well. Here you can see this length is given as h, 20 meters, 10 meters, C, A and B. So let's move forward with the first step. To find out the area of this trapezoid, let's divide it into two halves, as I said earlier. One triangle and the rest of it as a rectangle. So now if we calculate the area of the triangle and the area of the rectangle, we now get the area of this entire trapezoid. Alright, so let's begin with this. Area of triangle ECD, as you guys know, it's going to be 1 by 2 BH. And here the B or the base is represented through C and the height is represented through H. So we have the formula here 1 by 2 HC, H here and C the base, plus HA as in the area of this rectangle. Now you can see this length is denoted by A and this length is denoted by H. So 1 by 2 HC, area of the triangle, plus 1 by plus HA, the area of the rectangle, height into A. Alright, let's now move on to the second step. If you observe here, we can see that since h is common in both of the terms, we're bringing out h and keeping the rest in between. So h outside, c by 2, basically 1 by 2 c, and then a remaining after taking out h. We've got this formula now. So let's try to simplify it further. Now c by 2 plus a, we can't directly add it because they are both unlike as of now. However, we can convert a into 2a by 2, making it an equivalent fraction with the equivalent denominator. So 2a by 2, that means c by 2 plus 2a by 2 is just c plus 2a by 2. Alright, so we've got this part of the formula now. Next, 2a is just a plus a, 2 times a. So we've got that there as well. Now, if we move on, we finally get the converted step, as in h plus b plus a by 2, or in short terms height a plus c plus a is given here. C and a is equal to the entire length of b. So that is just b plus a by 2, which is height into sum of parallel sides by 2, which is the same as 1 by 2 h by b1 plus b2. The height, the sum of the parallel sides, this side and this side, a here and b c plus a by 2. Thereby we get the formula of 1 by 2 bh. Let's now move on to another shape as we understand the trapezoid. Area of a general quadrilateral. Now when you think of a quadrilateral, the first thing that comes in your mind is a square, a rectangle, possibly a parallelogram. But what about general quadrilaterals? The term any type of quadrilaterals. Let's check that out. This is going to be the figure. It's a parallelogram, right? You can infer that. However, we know parallelogram's area formula is ABH. However, here they haven't given the base nor the length of this side. So how do we figure out the area when it's given as such? You have a parallelogram, a diagonal passing through it, and a height 2, a height 1. That's what we're going to learn now. Area of a general quadrilateral when two heights with the diagonal are given is 1 by 2 d h1 plus h2. Now this is just so similar, actually same as the trapezoid formula, except the lengths are different. As in here, over 1 by 2 h last time, this is going to be 1 by 2 d, where d is the diagonal. h1 is the height given over here, and h2 is the height over here. So 1 by 2 d into h1 plus h2. This is the diagonal, height 1 and height 2. That's the area formula. Again, over memorizing and mugging up the formulas, let's figure how is the formula derived. Let's take a similar figure again, except we'll mark it A, B, C and D. Now for this formula, if you analyze this, we have two triangles over here. Now we can understand that these two triangles area added gives the area of the entire quadrilateral. So this is area of triangle ABC and triangle ADC. ABC and ADC. Next, we'll simplify their areas. Now ABC, the formula is 1 by 2 BH. So AC over here is the B, 1 by 2 B, and H1 is the height. So that is represented over here. And similarly for ADC as well, it's 1 by 2 AC, this length, and H2 over here. So now we've got the areas of both of them. Now how can we simplify this further? Very simple. Now since 1 by 2 AC is common in both of them, just take it out. You have factorized it, that's H1 plus H2. Now what is AC over here? AC is the diagonal of the entire quadrilateral. So the end formula gives us with 1 by 2 D into H1 plus H2. Very simple. Now another quadrilateral before moving on to our exercises. Area of special quadrilaterals. Now again, this also looks like a parallelogram, right? Let's now try using, now we can't use 1 by 2 BH. Let's try another one. The previous formula we learned. 1 by 2 D, H1, H2. They've given D2. That's great. So we have 1 over there. But they haven't given H1 or H2. Rather, they've given the diagonal. So how do we calculate that area? Let's see the formula. That's going to be 1 by 2 D1 into D2. Wherein D1 is the diagonal one, this side as in this diagonal, and D2 the other diagonal. So 1 by 2 D1 into D2. Again, let's figure out how is the formula derived. Let's take this same shape. Alright. ABCD marked with a point O in the middle. And equal sides. Okay. Now again, this must be easy to guess. Just like the last one, this also has two triangles if you figure that out. It's ACD plus the area of ABC. We've got that, right? Now let's simplify it yet again. Alright, so 1 by 2. Let's start off with the first triangle, ACD. 1 by 2 into AC and OD. Alright, we got that part of the formula. Same for ABC, triangle ABC, where 1 by 2 AC into OB. So now we've got that as well. So 1 by 2 AC into OD as ACD's area and ABC's area is 1 by 2 AC into OB. We've got that now. So let's simplify this. We have 1 by 2 AC taken out from both of them, just like the previous one, factorization. Alright, 1 by 2 AC and OD plus OB. Now, if you notice something, OD and OB are just equalizing to BD as a whole. The O is just the point in the middle, which we use as a height. So, we can just simplify this as BD and AC. So, if you notice that something again, AC is a diagonal, BD is also a diagonal. So, by simplifying this formula, we get the final formula as 1 by 2 D1 into D2 or 1 by 2 diagonal 1 into diagonal 2. Guys, thank you so much for watching part 1 of this mensuration chapter. We'll have 2 more parts where we detail out all the exercises and more topics such as volumes, surface area to come. Make sure to like and subscribe for more lessons and explanations.